A bigger fan does not automatically move more useful air.
First, define what bigger means: impeller diameter, wheel width, housing or opening, motor rating, and installation footprint are different dimensions. The correct comparison starts with the required airflow and pressure, not the outside size of a product. Installed airflow comes from an operating point. Each fan has a performance curve for specified speed, density, and test configuration. The connected filters, coils, ducts, grills, dampers, and fittings create a system resistance curve.
Their intersection determines the flow the system can actually use.
Imagine a large, slow fan and a smaller fan with a higher pressure curve. At low resistance, the large fan may lead. At the required pressure, the smaller fan may deliver more. Reverse the curves and the conclusion reverses.
Size alone cannot select the winner without a stated duty point.
Do not compare one free air maximum with another fan's pressure rated value. Free air means essentially no connected system pressure, while installed equipment adds resistance. Static pressure, total pressure, density, and measurement setup must use a common basis before any airflow number is comparable. Fan category and geometry matter alongside diameter. Axial, centrifugal, mixed flow, crossflow, and propeller designs occupy different pressure and flow envelopes. Blade shape, hub ratio, wheel width, housing, clearances, inlet count, and discharge arrangement can outweigh a simple diameter comparison. Fan laws help only when similarity assumptions hold. Geometrically similar fans, controlled density, appropriate speed and size range, and unchanged aerodynamic relationships are required. Tip speed, stress, Reynolds effects, compressibility, motor or drive power, temperature, and stable flow limits prevent unlimited scaling. A larger wheel at lower speed can be useful at some matched duties, but it is not always quieter, more efficient, or cheaper. Motor and drive efficiency, blade design, tonal noise, installation, and operating point all matter. Compare total input power and sound on a defined basis at the same airflow and pressure. Installation system effect can erase an expected size advantage. A close elbow, blocked inlet, abrupt transition, leakage, swirl, flexible connector, or poor discharge development changes the velocity profile and pressure loss. Two fans must see comparable boundaries before their catalog and field results can be judged fairly.
Outlet airflow is not total volume flow.
A small opening can produce high local velocity while moving less total air, and a large opening can feel gentle while carrying more. One anemometer reading cannot represent the area, define the plane, traverse, profile, density correction, steady state, and uncertainty. RPM, current, watts, and motor size are supporting measurements, not airflow meters.
RPM omits geometry and pressure. Current depends on voltage, phase, power factor, motor, drive, and load. Input watts include losses. Traceable airflow and pressure evidence is still required at the matched duty.
Procurement should compare the full application passport, duty point, air properties, fan category, arrangement, materials, motor, drive and controls, electrical supply, stable range, total input, sound method, environmental and listing needs, dimensions, access, guarding, supports, and certified or manufacturer data.
The conclusion is conditional. Choose the fan that meets the required duty and constraints, not simply the largest fan.
A size change is an engineering and safety change involving mass, inertia, structure, vibration, electrical protection, clearances, guarding, and commissioning. Never improvise a live swap or bypass energy control for a comparison.